integration. I know the topic sounds very complicated, but believe me, if we take care of a few things, it's going to be very simple. I don't think it's as tough as we make it to be. So let me start with my presentation today. Integration. What exactly is integration? The word calculus, integration is part of calculus in mathematics. Calculus comes from the Latin word small stone. So whenever we study things in small parts, differential calculus, we normally say is dy by dx. So what is that? What is the change of y when x changed by a very small amount? So that is differential calculus. That is, we break up things into small parts and we study it. That is differential calculus. Integral calculus is just the opposite of differential calculus. We join all these small pieces together and then we study the net effect. That is integral calculus. So we call integrals as antiderivatives. Because if we say that derivative of a function f dash x is fx, then integral of fx would be capital Fx. So that is why it is called the antiderivative. We said derivative of capital Fx was small fx. So integral of small fx would be nothing but capital Fx plus c. Let's just quickly go through what these mean. The elongated S symbol is the integral sign. The small fx, the function that you integrate, is called the integrand. Dx gives us that we are integrating with respect to which variable. Now c is called the constant of integration, right? So we know that the derivative of x is 1. So integral of 1 dx would be x plus c. Now why this c? Suppose I differentiate x plus 2. The derivative would still be 1. So when I say integral of 1 dx, it could be x plus 2. Similarly, derivative of x minus half would still be 1. So integral of 1 dx can be written as x minus half. Now, whenever we have a constant along with x, the derivative is going to come out to be 1. So when we integrate 1, we always write it as x plus c. The c is the constant of integration. Similarly, when we say, what is derivative of x to the power of n? It is n times x to the power of n minus 1. So when we say what is integral of x to the power of n? Of course, the power has to increase. So x to the power of n plus 1 upon n plus 1. So that when you differentiate this, we get x to the power of n. I hope we have all got the hang of it now. Derivative of cos x is minus sin x. So integral of sin x would be minus cos x. So similarly, proceeding with this logic, we know the derivatives of the trigonometric functions. So we integrate the derivatives, we get back the trigonometric functions. Like derivative of cosec x is minus cosec x cot x. So integral of cosec x cot x would become minus cosec x plus c. Similarly, derivative of log x is 1 by x. Integral of 1 by x dx, we put it as log of mod x plus c. We are aware that log is not defined for negative real numbers. So we use the modulus sign, log mod x plus c. Derivative of ex is ex, so integral of ex also remains the same. Derivative of a to the power of x is a to the power of x log a. So integral of a to the power of x would be a to the power of x upon log a plus c. For inverse trigonometric functions, I think we are all aware, derivative of sine inverse x, 1 upon root of 1 minus x squared. Cos inverse x derivative would be negative. So integral of 1 by root 1 minus x squared dx is nothing but sine inverse x plus c. So moving further, let's see how do we integrate when we have a number of terms. If we have k times dx, it would be k outside, integral of 1 into dx. Integral of 1 into dx we just saw is x. So it will be kx plus c. If we multiply a function by a constant, then the constant can be taken out. So it will be a times integral of fx dx. Suppose we have a sum or difference of two functions to be integrated. It would be integral of the first one that's written, plus or minus, whichever sign you have here, the same sign would be repeated, integral of the second one. And this we just saw that integral of x to the power of n dx would be x to the power of n plus 1 upon n plus 1 plus c. Now this you can apply for any real number n except minus 1. Why minus 1? Yes, you're right. Integral of x to the power of minus 1 is nothing but 1 upon x. And integral of 1 upon x is log mod x plus c. Let's go through some examples quickly. The simple one, if I have to integrate 5x plus 7, I first split them into two integrals. Integral 5x dx plus integral 7 dx. 5 is a constant multiplied with x, so we can write it 5 times integral x into dx plus integral 7 into dx. So derivative of x, the power is 1. So it becomes x to the power of 1 plus 1, that is 2 divided by 2 plus c1. Now 7 times dx is integral 7 into 1 dx, so that is 7x. So constant of integration plus c2. So we combine all the constants of integration and write it as 1. So the answer becomes 5 by 2 x squared plus 7x plus c. So moving on to one more example. 6x to the power of 4 minus 9x squared dx minus root x. Now root x is nothing but x to the power of half. So as I had just said, x to the power of half means it will be x to the power of half plus 1 divided by half plus 1. So half plus 1 is 3 by 2 divided by 3 by 2. So we write it as 2 by 3 x to the power of 3 by 2. And I'm sure the first two integral part you all would have been able to do. So once we know how to integrate small functions, this does look a little complicated. But since the denominator is simple, I first try to separate them. So this works out to be 3 tan theta upon cos theta minus 4 cos square theta upon cos theta. So when I simplify this, we get it as sec theta tan theta. I hope it's familiar. Sec theta into tan theta is nothing but the derivative of, yes, you're right, sec theta. And integral of cos theta. Now cos theta is the derivative of sine theta. So integral cos theta is nothing but sine theta. So we get the answer 3 sec theta minus 4 sine theta plus c. Moving further, we can also use some trigonometric functions, formulae, identities we learned to integrate. Like for example, if I have 2 sine x cos x, it can be written as integral sine 2x. So integral sine 2x would be nothing but integral of sine 2x would be cos minus cos 2x by 2 plus c, right? Sine square x is, as it is, I cannot integrate. So we write sine square x as half 1 minus cos 2x. So integral of 1 becomes x. Integral of cos 2x becomes sine 2x by 2. So we get half into x minus sine 2x by 2 plus c. So same thing we can apply if you have to integrate cos square x. Now to integrate tan square x. Tan square x as such is not the derivative of any function. But if we write it as sec square x minus 1, we know that sec square x is the derivative of tan x. So what would be integral of tan x dx? It would become integral of sec square x minus 1 dx. So that makes it integral of sec square x would be tan x minus integral of 1 dx is x plus c. So similarly, we can do it for cot square x as well. Now, if I have to integrate sine cube x by the sine 3x formula, sine cube x can be written as 1 by 4 sine x minus sine 3x. Similarly, cos cube x using cos 3x formula can be written as, so if I have to integrate cos cube x dx, it would be 1 by 4 times cos 3x plus 3 cos x dx. Integral of cos 3x is sine 3x upon 3, and thrice integral of cos x will become sine x. So 1 by 4 sine 3x by 3 plus 3 sine x plus c. So this is how we use trigonometric identities. Now suppose if I have to integrate 2 sine 3x cos 5x dx. Now out of these formulas written on top, you can see that the third one is what I can use. 2 sine a cos b is sine of a plus b plus sine a minus b. So a here is 3x, b here is 5x. So sine a plus b, 3x plus 5x will make it 8x, and 3x minus 5x will make it minus 2x. And we know that sine of minus theta is minus sine theta. So we write it as minus sine 2x. So integrating this, sine 8x dx becomes minus cos 8x by 8, and minus sine 2x dx becomes plus cos 2x by 2. So this is how we use trigonometric identities to integrate. The next method I would like to discuss is integration by substitution. So first, when do we use this? If we have plus or minus between the functions, we just separate the integral and we integrate them. But suppose if we have a product or a division of functions, then the first thing you have to check is the functions that are given. Is there a function whose derivative is also present in that question? Now, for example, in this question, This is f to the power of nx, means it is fx whole to the power of n. And f dash x is nothing but the derivative of fx. So what do? We take, we take fx as t. Now I need the value of dx. So we differentiate both the sides by x. So what do we get? F dash x dx is equal to dt. Derivative of fx becomes f dash x into dx equal to dt. So f dash x dx, we replace it by dt. So the integral becomes t to the power of n dt equal to, so what is integral of t to the power of n dt? T to the power of n plus 1 upon n plus 1 plus c. So what was t? T was fx. So it becomes f to the power of n plus 1 x upon n plus 1 plus c. So this part you can use it as a formula. And when do we use it? When we have a function and its derivative present. For example, we have to integrate sine to the power of nx cos x dx. So there's a sine function, there's a cos function. So which one can we consider as the derivative of the other? Any one of them, right? But sine here has the power x. So what do? We will say let sine x be equal to t. Differentiating both sides with respect to x, we get cos x is equal to derivative of t with respect to x, we write it as dt by dx. This I can rewrite it as cos x into dx is equal to dt. So what does the given integral become? I had sine x to the power of n. Sine x is t now. So t to the power of n into value of cos x dx is dt. So instead of cos x dx, I write it as dt. So integral of t to the power of n dt would be t to the power of the power, I have to add 1 upon n plus 1 plus c. But in this question, what is t? It is sine x. So sine to the power of n plus 1 x upon n plus 1 plus c would be the answer. Right? So whenever you have product of two functions, the first thing you're going to check is, can I find a function and its derivative present in the question? If so, then you take the function as t, the derivative will automatically become a part of the dt, right? Moving further, suppose we have two functions divided. Always check if numerator is derivative of the denominator. Check if numerator is the derivative of the denominator. Why? Because you could substitute the numerator as t. You can substitute the denominator function as t. After this, whenever we substitute, we have to differentiate because we need the value of dx. So when you differentiate this, you get f dash x dx is equal to dt. So substitute it back in the given integral. So f dash x dx becomes part of dt and fx is t. So what is integral 1 by t dt? Yeah, log mod t plus c. But what was t? It was fx. So log mod fx plus c. So this also you can use it as a standard result. So integral f dash x upon fx dx would be equal to log mod fx plus c. So let's take up a few examples based on this. Suppose the given integral that you have is I equal to integral sec square x upon tan x dx. So what do we observe here? Sec square x is nothing but the derivative of tan x. So if you remember that integral f dash x upon fx dx is log of mod of denominator, that is fx. Then the answer to this integral, you can directly write it as log mod tan x plus c. Let me take one more example. Suppose I have x, or let me say 2x plus 4 upon x square plus 4x minus 7 to integrate. Looks quite complicated, but is it? What is the derivative of the denominator? Yes, 2x plus 4, which is there in the numerator. So what is the answer to this? Log mod x square plus 4x minus 7 plus c. Simple enough. So whenever you have product of two functions or quotient of two functions, that is two functions divided, always check if one function is the derivative of the other. Okay. One more example. Now this. Which function? Okay, here we have two functions, 36x squared and the fourth root of 6x cubed plus 5. This looks quite complicated. So let me check what is the derivative of 6x cubed plus 5. That would be 3 into 6. 18x square, fine, plus 0. Derivative of constant is 0. But instead of 18, I have 36. That's okay. Let me take out 2 common, because 2 into 18 is 36, right? Or I can say I multiply and divide by 18. 36 by 18 is 2. So the question reduces to 4th root of 6x cubed plus 5 into 18x squared dx. Okay. So if you substitute 6x cubed plus 5 as u, you can take it as u, v, any variable you're comfortable with. Then derivative of u would become 18x squared dx. Right? So this question reduces to twice integral of u to the power of 1 by 4 du. So your n in this question is 1 by 4. So what would be the integral? N plus 1. So 1 by 4 plus 1 is 5 by 4. So 2 into u to the power of 5 by 4 upon 5 by 4 plus c. Right? So this becomes 8 by 5 u to the power of 5 by 4 plus c. And once you substitute the value of u, you get your answer. Now let's move on to the next way of integrating. Suppose I have a quotient of functions where the numerator is not a derivative of the denominator. If numerator is a derivative of the denominator, we have seen we will use method of substitution, or we can use the results that we have just done. But suppose if I have a fraction or a rational function where the numerator is not a derivative of the denominator, then we can use the method of partial fractions, meaning the given quotient, we try to reduce it into simple fractions. For example, if I have 5 by 6, what are the factors of 6? Factors of 6 are 2 and 3. So I try to write one fraction with denominator 2 and one fraction with denominator 3. So that can be written as 1 by 2 plus 1 by 3. So 5 by 6, I have been able to write it as 1 by 2 plus 1 by 3. So similarly, a rational expression or rational function, we try to divide it into simple fractions which we can then integrate. But whenever you have to apply partial fractions, one thing you have to be careful about. Check what is the degree of numerator. If degree of numerator is less than the degree of denominator, we directly split it into partial fractions. If not, we have to divide. I hope we remember how to divide a polynomial by another polynomial. So what is division algorithm? When we divide, we can write dividend upon divisor as quotient plus remainder upon divisor. I mean, these terms might seem confusing. What I'm trying to say is, suppose I have to divide 27 by 4. So I know that 6 4s are 24 and the remainder is 3. So quotient is 6 plus remainder is 3 upon divisor is 4. So I can write 27 by 4 as 6 plus 3 by 4. So similarly, if I have a polynomial upon another polynomial where the degree of numerator is more than the degree of denominator, I divide it, rewrite it like this, and then we try to integrate. So which are the different forms? Suppose I have a polynomial in the numerator upon another polynomial in the denominator, which I have to see is fully factorized. Suppose I have two linear terms, x minus a into x minus b. So as I wrote 5 by 6 is equal to half plus 1 by 3. Similarly, this I try to write it as a constant upon x minus a plus another constant upon x minus b. And then we try to find the value of a and b. We would be coming to that when we do the examples. Suppose I have another one of the type, a polynomial upon square of a linear into another linear, that is x minus a whole square. Then I first split it as, what are the factors of the denominator here? X minus a whole square, and x minus b. There are three factors. So I have to have one fraction for each. So it will be a upon x minus a plus b upon x minus a whole square plus c upon x minus b. The third type could be, I have a linear, but the quadratic that I have cannot be factorized into simple factors. Okay, that is, it doesn't have any real factors. So in that case, I have to write one fraction with denominator x minus a and the other fraction with denominator x squared plus bx plus c. So when I have a linear, the numerator is just a constant. Plus, when the denominator is a quadratic which cannot be factorized further into real factors, the numerator, I take it as a linear. I'm repeating it. Whenever the denominator is a quadratic, it cannot be factorized further, the numerator has to be linear, that is bx plus c. So that is the difference here. So basically, these are the three different ways of using partial fractions. So before using partial fractions, what are the things to be seen? Degree of numerator should be less than degree of denominator, and the denominator should be in a fully factorized form. And the third thing is, when you're splitting it into partial fractions, if the denominator has linear factors, the numerator, we take it to be constants. But if the denominator is a quadratic, then the numerator has to be taken as linear. Okay, so let me take one example here. Suppose if I have to integrate, I'm taking I as integral x square plus x plus 1 upon x plus 1 whole square into x plus 2 dx. Now, here, what are the things to be checked? First of all, is the degree of numerator less than the degree of denominator? What is the degree of the numerator? 2. Degree of denominator would be 2 plus 1, so that is 3. So the first condition is fine. So I can use partial fractions. But before that, I also said when you have two functions divided, let's check if numerator is a derivative of the denominator. In this case, I would be getting x cubed term. I would be getting an x squared term. So x cubed term, the derivative would be 3x squared. X squared term, the derivative would be 2x. So definitely this cannot be put in the form of derivative of the denominator. So the only method that we now are going to use is partial fractions. So I write x squared plus x plus 1 upon x plus 1 whole square into x plus 2. Now this function, rational function, I have to split it into smaller fractions, smaller rational functions. So what would be the denominators? The denominators would be the factors of the denominator here. So what are the factors of x plus 1 whole square? One of them is x plus 1. The other factor is x plus 1 whole square. And now we are left with this, that is x plus 2. Clear? Now, what if I have to write the numerator for each one of them? Now, denominator is x plus 1 is linear, so numerator would be a constant. I call it a. Here again, it is square of a linear, so numerator would be a constant p. This is again linear, so numerator would be c. Right? Now, let me simplify this. So I get x squared plus x plus 1 upon x plus 1 whole square into x plus 2. The common denominator here would be x plus 1 whole square into x plus 2. So a times, I have only x plus 1 here, and this is x plus 1 whole square. So by that, it would be x plus 1 into x plus 2 plus b into x plus 2 plus c into x plus 1 whole square. This is by the simple division or adding of fractions that we have done. Now, we observe the denominator on both sides are equal and the two functions are equal. So definitely the numerator have to be equal. So that means x squared plus x plus 1 is equal to 8 times x plus 1 into x plus 2 into b times x plus 2 plus c times x plus 1 whole square. Now we don't know what are a, b and c. We need to find the value of a, b and c. So one way is to compare the coefficients. But that is a little cumbersome. So what we do is we can give values to x and find the value of a, b and c. So for example, if I take let x be equal to, so since I am choosing the values, I try to choose such values so that some of the terms become 0. So if I take let x be equal to minus 2. Why did I choose minus 2? Because if x plus 2 is 0, then x is equal to minus 2. So what is the left hand side? Minus 2 square is 4 plus minus 2 plus 1. And the right hand side, it would be a into 0 plus b into 0 plus c into minus 2 plus 1 is minus 1, whole square is 1. So we get the value of c as 3. Okay. So proceeding like this, the next we get the value of a. So for that, we'll take let x be equal to minus 1. So if you take x to be equal to minus 1, substitute it on the left hand side. So it will be minus 1 square plus 1 plus 1. So what does it become? Yes, the answer for A comes out to be minus 2. Next, I need the value of B. So let me take x, let x be equal to 0. So the left hand side becomes 1. So when you substitute 0, you will get 2a plus 2b plus the value for c, that is c. So substitute the value of a and c. So you would get the value of b as 1. Because 2 into minus 2 is minus 4 plus 3 is minus 1. Okay. So 1 plus 1 is 2. 2 by 2 is 1. So you get the value of b to be 1. So now what happened to our question? Our question was x squared plus x plus 1 upon x plus 1 whole square into x plus 2 dx, which we noted as a upon. So value of a minus 2 upon x plus 1 plus b upon. Value of b is 1 upon x plus 1 whole square plus c upon. value of c was 3 into x plus 2. So when I say integral, I can separate these integrals. So the whole question, which looked quite complicated, has now come in a simple form. Now, how do I integrate minus 2 upon x plus 1? So as I said, whenever you have quotient, find the derivative of the denominator. The derivative of the denominator is x plus 1's derivative is 1. So I can write this as my into integral 1 upon x plus 1 dx plus. Now here I have x plus 1 whole square. So if I substitute x plus 1 as t, dx would become dt. So this would reduce to the form dt upon t square plus 3 into derivative of x plus 2 is 1, which we have it in the numerator. So I rewrite it as it is. So numerator is a derivative of denominator. So the integral would be log mod x plus 1 plus this, I can write it as t to the power of minus 2 dt. So the integral would be t to the power of minus 2 plus 1 upon minus 2 plus 1. Integral of 1 upon x plus 2. Derivative of x plus 2 is 1, which is present in the numerator. So the integral would be log mod x plus 2 plus c. So your final answer could be minus 2 log mod x plus 1 minus 1 by t. T is nothing but x plus 1 plus 3 log mod x plus 2 plus c. So this is method of partial fractions, right? Let me just quickly take one more example. Suppose I have to integrate x squared plus x plus 1 I have integral x squared plus x plus 1 upon x plus 2 into x squared plus 1. Let's just see how to split it into partial fractions. X squared plus x plus 1. What is the first thing to be done? Check the degree. Degree of numerator is 2. Degree of denominator would be 1 here into 2 here plus 2 here. So that is 3. So we can split into partial fractions without doing anything else. Next thing, x plus 2 cannot be factorized further. Similarly, x squared plus 1 cannot be factorized further. So I would be writing two fractions, one with denominator x plus 2, the other one with denominator x squared plus 1. Right? Now, x plus 2 is linear. So what do I put in the numerator? A constant. Now, x squared plus 1 is a quadratic. So numerator has to be linear. What do we mean linear? A polynomial with x term and a constant. So we write it as bx plus c. Right? A common denominator, x plus 2 into x squared plus 1. So ये बना a into x squared plus 1 plus px plus c times x plus 2। तो दोनों तरफ डिनोमिनेटर सेम है तो न्यूमरेटर्स भी सेम होंगे। अगर एक फ्रैक्शन में अगर डिनोमिनेटर्स सेम है और फ्रैक्शंस इक्वल हैं तो न्यूमरेटर्स भी सेम होंगे। सो एक्स स्क्वायर प्लस 1 बनेगा a इंटू एक्स स्क्वायर प्लस 1 प्लस bx प्लस c इंटू एक्स प्लस 2। अभी हमें a, b और c की वैल्यूज निकालनी है तो उसके लिए हम ले सकते हैं x की वैल्यू 0, उससे हमारा वैल्यू निकल सकता है। पहले हम ले सकते हैं x की वैल्यू -2 सो दैट ये 0 बन जाए और a की वैल्यू निकल जाए। जब a की वैल्यू निकल गई, x 0 रखेंगे तो c की वैल्यू निकलेगी। अब b की वैल्यू निकालने के लिए हमें a पता है और c पता है तो x की आप कोई भी वैल्यू दे सकते हैं, सपोज 1, एंड देन यू कैन फाइंड द वैल्यू ऑफ b और उसको वापस इस इक्वेशन में डाल देंगे ताकि इंटीग्रल बन जाएगा इंटीग्रल ऑफ दिस फ्रैक्शन प्लस इंटीग्रल ऑफ दिस फ्रैक्शन, राइट। तो a, b और c की वैल्यूज मैं आपको बता देती हूँ, ठीक है। तो हमारा क्वेश्चन बना इंटीग्रल, क्वेश्चन बना a की वैल्यू आती है हमारी 3/5 इंटीग्रल 1 अपॉन x प्लस 2 dx, b की वैल्यू आती है 2/5x और c की वैल्यू 1/5 अपॉन x स्क्वायर प्लस 1 dx। अब इसको कैसे करेंगे? डिनोमिनेटर x प्लस 2 है, डेरिवेटिव उसका 1 न्यूमरेटर में है, तो ये तो सीधे सीधे बन गया log mod x प्लस 2। अब ये जो है इसको हम अलग कर लेते हैं। सो 2/5 टाइम्स x अपॉन x स्क्वायर प्लस 1, 1/5 टाइम्स 1 अपॉन x स्क्वायर प्लस 1 dx। तो ये हो गया 3/2 log mod x प्लस 2 प्लस, अब डिनोमिनेटर की डेरिवेटिव क्या है? x स्क्वायर प्लस 1 की डेरिवेटिव वो है 2x। तो x तो है हमारे पास, मिसिंग क्या है? 2। तो हम 2 से मल्टीप्लाई और डिवाइड, यानी कि न्यूमरेटर और डिनोमिनेटर को 2 से मल्टीप्लाई कर देते हैं। तो अभी क्या बचा? 2 कटा, सो 1/5 न्यूमरेटर डेरिवेटिव ऑफ डिनोमिनेटर, तो log mod डिनोमिनेटर प्लस 1/5। अब 1/x स्क्वायर प्लस 1 है डेरिवेटिव tan इनवर्स x का, तो हमारा आंसर ये रहेगा, राइट। आई होप यू हैव ऑल अंडरस्टूड। ऑफ कोर्स दिस कम्स विद लॉट ऑफ प्रैक्टिस। इंटीग्रेशन एक ऐसी चीज है जिसमें हमें बहुत प्रैक्टिस करनी पड़ती है। लेट मी क्विकली गो थ्रू सम पर्टिकुलर फंक्शंस। अगर हमारे पास इंटीग्रल dx अपॉन एक्स स्क्वायर माइनस ए स्क्वायर, 1 अपॉन ए स्क्वायर माइनस एक्स स्क्वायर, 1 अपॉन एक्स स्क्वायर प्लस ए स्क्वायर इन फॉर्म के हो, तो इनमें हम ट्रिग्नोमेट्रिक फंक्शन सब्स्टिट्यूट करके इंटीग्रेट करके ये फॉर्मूले निकालते हैं। Just now we saw integral 1 upon x square plus 1 is tan inverse x. यहाँ पे है x square plus a square, तो ये बनता है 1/a tan inverse x by a plus c। अब x square minus a square है, इसको अगर हम फैक्टराइज करें तो क्या बनेगा? x माइनस ए इंटू एक्स प्लस ए। अगर हम पार्शियल फ्रैक्शंस यूज करें और सिंप्लीफाई करें तो हमारा आंसर बनेगा 1/2a log mod x माइनस ए अपॉन एक्स प्लस ए। और अगर हमारे पास है 1/a² माइनस एक्स स्क्वायर इंटीग्रल dx, देन इट बिकम्स इसका उल्टा, यानी कि a प्लस एक्स अपॉन a माइनस एक्स मॉड 1/2a। ठीक है, सो दीज फॉर्मूले यू आर सपोज टू रिमेंबर। अब इन्हीं के साथ अगर हम रूट लगा दें डिनोमिनेटर पे, आपको याद होगा इंटीग्रल 1/√1 माइनस एक्स स्क्वायर है साइन इनवर्स एक्स। तो इंटीग्रल dx अपॉन रूट 1 की जगह अगर एक्स स्क्वायर माइनस एक्स स्क्वायर है तो दैट बिकम्स साइन इनवर्स x बाय a प्लस c। ठीक है, बाकी दोनों केसेस में लॉग मॉड x प्लस जो भी डिनोमिनेटर में है वो पूरा का पूरा प्लस c। सो इंटीग्रल dx अपॉन रूट ऑफ एक्स स्क्वायर प्लस ए स्क्वायर बनेगा लॉग मॉड x प्लस जो भी डिनोमिनेटर में था दैट इज रूट ऑफ एक्स स्क्वायर प्लस ए स्क्वायर प्लस c। तो इनको याद करना इतना मुश्किल भी नहीं है। जब रूट नहीं है तो बाहर कुछ आता है, ये याद रखिएगा। एक्स स्क्वायर माइनस ए स्क्वायर और ए स्क्वायर माइनस एक्स स्क्वायर में जब माइनस होते हैं तो 1/2a से शुरू होता है। लॉग मॉड एक्स माइनस ए अपॉन एक्स प्लस ए, और ए स्क्वायर माइनस एक्स स्क्वायर है तो लॉग मॉड ए प्लस एक्स अपॉन ए माइनस एक्स। और एक्स स्क्वायर प्लस ए स्क्वायर आपको याद रखना पड़ेगा, टैन इनवर्स एक्स है एक्स स्क्वायर प्लस 1 का, तो 1/a टैन इनवर्स एक्स बाय ए प्लस सी। जब यही चीजें विद रूट है डिनोमिनेटर में तो पहले कोई कांस्टेंट्स नहीं है, इट डायरेक्टली स्टार्ट्स विद लॉग मॉड एक्स प्लस जो भी डिनोमिनेटर में था रूट एक्स स्क्वायर माइनस ए स्क्वायर प्लस सी। और अगर 1/रूट ऑफ 1 माइनस एक्स स्क्वायर यानी साइन इनवर्स एक्स वाले फॉर्म में है 1 की बजाय ए स्क्वायर, तो ये बनेगा साइन इनवर्स एक्स बाय ए प्लस इंटीग्रल dx अपॉन रूट ऑफ एक्स स्क्वायर प्लस ए स्क्वायर बनेगा लॉग मॉड एक्स प्लस रूट एक्स स्क्वायर प्लस ए स्क्वायर प्लस सी। अब ये देखते हैं ये कहाँ यूज होती हैं। Whenever you have integrals of the types constant upon a quadratic या constant upon root of a quadratic या linear upon quadratic या linear upon root of quadratic, वहां सब ये particular functions use होती हैं। कैसे? Let's take an example. Suppose I have 1/root, so this is a quadratic 9x square plus 6x plus 5 and the numerator is a constant. So I try to use the particular function formulae. So for that, I have to bring it to that form. So the denominator 9x square plus 6x plus 5, इसको हम completing the square से factorize करते हैं। यानी कि 9x square को हम लिख सकते हैं 3x whole square प्लस मुझे लिखना है a प्लस बी होल स्क्वायर के फॉर्म में। तो a स्क्वायर तो आ गया मेरा, द सेकेंड टर्म इज 2 into a I now know is 3x। अब b क्या होनी चाहिए कि मेरे पास आए 6x, so 2 into 3x is 6x, so b should be 1। अब b स्क्वायर को हम ऐड करते हैं और सब्ट्रैक्ट करते हैं, यानी कि आई ऐड 1 स्क्वायर एंड सब्ट्रैक्ट 1 स्क्वायर प्लस 5, राइट। अब इन टर्म्स को आप अगर देखो, सो दिस इज इन द फॉर्म ऑफ a प्लस b होल स्क्वायर, यानी कि 3x प्लस 1 का होल स्क्वायर माइनस 1 प्लस 5 is plus 4। So the given integral now can be written as 1/√3 3x plus 1 का होल स्क्वायर प्लस 2 स्क्वायर dx। ओके, सो अब ये किस फॉर्म में आया? ये है फॉर्म इंटीग्रल 1 अपॉन एक्स स्क्वायर प्लस ए स्क्वायर के फॉर्म में। और ये था क्या? 1 बाय ए tan इनवर्स x बाय ए प्लस सी। ठीक है, पर यहाँ एक चीज का ध्यान रखिए, जो ये स्क्वायर का है x, डेरिवेटिव 1 होनी चाहिए। पर यहाँ पे इसकी डेरिवेटिव क्या है? 3x प्लस 1 की 3, राइट? तो अगर ये कंफ्यूजन हो रहा हो, आप एक काम कर सकते हैं, आप कह सकते हैं लेट 3x प्लस 1 बी इक्वल टू t, सो 3 dx इज इक्वल टू dt। तो आपका इंटीग्रल बना 1 अपॉन t स्क्वायर प्लस 2 स्क्वायर dx is dt by 3, यानी कि 1 by 3 dt. So this is nothing but 1 by 3. ये फॉर्मूला लगाते हुए 1 by a. a is square of the constant, तो 1 by a यहाँ बना 2 tan inverse t by 2 plus c, यानी कि 1 by 6 tan inverse t है 3x plus 1 by 2 plus c would be your answer, right? So I hope you have understood some methods of indefinite integrals. मेरे पास एक और example है which I would like to do it quickly if time permits. अब यहाँ पे है कांस्टेंट अपॉन रूट ऑफ क्वाड्रेटिक। जब भी ऐसे हो तो क्वाड्रेटिक को हमें कंप्लीट द स्क्वायर्स करना है। तो 7 माइनस एक्स स्क्वायर, 7 माइनस 6x माइनस एक्स स्क्वायर को कभी भी कोई स्क्वायर ऑफ अ नंबर इज नेवर नेगेटिव। यहाँ पे माइनस है तो हम माइनस को कॉमन लेके इसको लिखेंगे एक्स स्क्वायर प्लस 6x माइनस 7। अब x स्क्वायर प्लस 6x माइनस 7 को कंप्लीटिंग द स्क्वायर मेथड से लिखेंगे x होल स्क्वायर प्लस 2 इंटू x इंटू वॉट वुड गिव मी 6x। जी हाँ, 3। यानी कि b की वैल्यू हो गई 3, तो b स्क्वायर को ऐड करना है, यानी कि 3 स्क्वायर ऐड किया तो सबट्रैक्ट भी करेंगे एंड माइनस 7 एज इट इज। तो ये बना x प्लस 3 का होल स्क्वायर, ये 3 टर्म्स बने x प्लस 3 का होल स्क्वायर माइनस 9 माइनस 7 यानी कि माइनस 16, राइट? पर हमारे डिनोमिनेटर में क्या है? माइनस ऑफ एक्स स्क्वायर प्लस 6x माइनस 7 चाहिए हमें, तो ये बन जाएगा 16 माइनस x प्लस 3 का होल स्क्वायर। तो गिवन इंटीग्रल बना 1 अपॉन रूट ऑफ 16 माइनस x प्लस 3 का होल स्क्वायर dx। बिल्कुल सही। अब हम फॉर्मूला कौन सा लगाएंगे? dx अपॉन रूट ऑफ a स्क्वायर माइनस एक्स स्क्वायर। वो क्या था? साइन इनवर्स x बाय a। तो ये फॉर्मूला लगाने से पहले आप देखेंगे कि ये स्क्वायर टर्म में जो है इसकी डेरिवेटिव क्या है? इसकी डेरिवेटिव है 1, तो हम डायरेक्टली लगा देते हैं। तो ये बनेगा साइन इनवर्स x प्लस 3 अपॉन a। a क्या है? 16 कैन बी रिटन एज 4 स्क्वायर, सो a है 4 plus c. So quickly let me just go through what we have done today. We saw what integration is. We did method of substitution using trigonometric ratios, कैसे हम integrate कर सकते हैं, कैसे हम partial fractions use करते हैं integrate करने के लिए, or how we have special integrals to integrate. So there are few more methods, क्योंकि इंटीग्रेशन इतना वास्ट चैप्टर है, वो 1 घंटे में पूरा करना थोड़ा मुश्किल काम है, राइट? तो होपफुली अगले टाइम अगर हम मिले तो हम आगे इस पे चर्चा करेंगे. So thank you so much NIOS. Thank you viewers. Namaskar.